If I am given a function and I find f prime, if I plug a 2 into f and I get 7 out, what does that mean? Yep. Plug a 2 into f and I get a 7 out. What does that mean? Yeah, so f goes through what point? 2, 7. Because for an input of 2, the output is 7. So f's job is to tell me all the y's, right? So when I plug in a specific x, I get a specific y. If I plug a 2 into f prime and I get 1, that tells me that at 2, the slope through 2, 7 is 1. So it's going through the point 2, 7 with a slope of 1. So it's going to go up from there, at least for a little bit. Maybe it turns, maybe it goes steeper. Who knows? Good so far? Okay. Anytime I plug a number into f prime, the output tells me about the slope. When I'm making a sign diagram for f prime, and I plug a number in, let's say that I plug a, well, let's do a concrete example. Let's say I get f prime is 2x minus 1 squared x plus 3, yes? Let's see, that's my f prime, yes? What are my zeros?
1,
When I plug like a 0 in, my result is going to tell me the slope there. But when I'm making a sign diagram, I don't care. I don't need to get so specific. I just need to know, is it going up or down? That's all I want to know right now, right? So when I plug a 0 in, I get positive times positive. Is that cool? Because negative 1 squared is positive, 0 plus 3 is positive. So through this whole area, it's positive. So pretty cool with that. Why could I just put pluses in that whole region?
honestly, I'm not sure.
Is my derivative continuous across that region? If it,
That's a yes.
Yes. If it wasn't, wouldn't I have got like an undefined point and I would have put a u over it? Okay, so the only place that the slope can go from going up to down is around where it goes to 0. I mean, if my function is positive here and negative here and it's continuous, what must happen between? If it's above the x-axis and it's below the x-axis and it's continuous, what has to happen in between? Here's the x-axis. I'm above the x-axis, I'm below the x-axis. It's continuous. What must I do to get to, well, I have to cross the x-axis. Meaning the output has to be 0 somewhere between. So where's the only places that it could change sign? Around where it's 0. So that's why we only have to, or undefined, right, more generally. That's why we only have to plug 1 point in, and then I know exactly what's happening in the whole region. Between negative 3 and 1, what is this function doing? Going up, increasing. Because I know I got a positive in there, yeah? If I plug in a 2, I still get positive, yes? Positive and positive and positive. But if I plug in a negative 4, I get positive times negative. So what's it doing here? Up to negative 3, what's it doing? Going down. Then it's flat for a moment, yes? And then it's going up. So what's true about negative 3? That is the x value of a location of a local min. That's it. If this was a sign diagram for the second derivative, then this would be concave down, this would be concave up, this would be an inflection point location. But do you notice, if I just gave you this picture, you wouldn't know which derivative I'm looking at. Here I told you f prime, but the picture would look the same if this was f double prime. My interpretation would be different because the function I would be evaluating, the function we're looking at right now tells me slope. What's related to slope? Increasing, decreasing. What's related to that? Max, min. Go down to it, up from it, that's a min. If it was f double prime, it could look exactly like this, but now my interpretation, since it's f double prime, this would be concave down. This would be concave up. This would be an inflection point. So to me, it's kind of nifty that the work for f prime, the sign diagram, and the work for f double prime, they're the exact same work. It's just the interpretation is different because f prime means one thing, f double prime means another. Is that better? Okay. All right. So hopefully you did this kind of thing twice on the quiz. Okay. Anything else from the quiz? Anything else, either specific or general? Anything you don't quite get yet?
Oh,
Yes.
It was one kind of bothered me. I remember, like, honestly, okay, I remember earlier. The fact, I wanted to the fact that there was that Chad was treating the primes as like separate functions. It kind of threw me off because it was asking for the inflection point for the third function, but to get the inflection point for a function, you're supposed to get the square root of that, right?
Okay. So if I
Sorry.
if I give you f of x, and that's all I give you, and say where's the inflection points? What do you have to find? Beautiful. What did I do though? Did I make you find that? I just gave it to you.
Yeah.
So the instant you're like about to do work that requires a second derivative, you go, oh good, Jeff gave it to me. Do you see what I mean? So it's what was the only function we were analyzing? There was one function we were analyzing, f.
Right.
That's what I needed a graph for. How were we analyzing f? We were using first derivative to analyze if it's going up or down. We're using second derivative to analyze if it's concave up or concave up or concave down.
Yeah.
Yes. You with me? There was one function to graph, and we were gathering information about it using the first and second derivatives. So normally you would have had to calculate the second derivative on your own. Now listen, Ezekiel, that would have been a third function. I agree with you. It's like I gave you an f. If you do a derivative, that's f prime. That's another function. And f double prime is another function. But f prime and f double prime are functions that describe things about f. That's their job. They came from f. They describe f. We use it to analyze f. Okay. Is that all right? So so I didn't want you to get stuck on the derivative. I wanted to test, can you use the derivative to investigate things? So I didn't want to make today's quiz just about the derivative. If I were to take the derivative of the function you guys had, what rule would you use? Yes, you might not remember your exact function, but it was a product of two functions. You have to use product. Okay. Anything else? Specific, general, or from homework or whatever? Okay. I think I got it. Yeah, I did. I finally got the 4-7 homework up with WebAssign, so you guys could work on that. So let's do this. Does everybody have a sheet? Where to put it? Oh, holy sheet. This sheet. Let me get a clean one, because where'd I put them? Here. Yeah. Okay. So what I want to do is I want to finish up the problem we started yesterday. And then I want to do one more example with you. Then we're going to take a break. And when we come back from break, you guys are going to work in groups on another sheet with a full example. I've got the answer key for this, so I'll see what I want to do. Well, I do want to finish this one because I told you yesterday we finished this one together. If you weren't here yesterday, This is the last problem. If you turn it on the back, it's the last problem, right? Number 4. This one, I just wanted to do a little side review of the formulas for arc length and area of a sector. Very quickly. Did I ask you guys about radians?
Yes.
Alright, now listen real quick, listen real close. If you feel like you've never heard of radians, see me, because a big prereq for this course is trigonometry. I'm gonna assume you know what sine of pi over 3 is, and you can tell me what it is. If that's not true, I'm gonna review it a little bit, but I'm assuming we know. I mean, we've already hit trig. We've already seen trig. So if you still aren't sure about trig, you wanna get that filled in. You have to know this stuff. Radians. How many degrees in a circle? Let me see if I can do this really quickly. 360. Do you guys know why?
Because it's based on the
Babylonians. Yeah.
Babylonians.
But did it have to be 360 is a better question.
No.
It could have been 400. Isn't 400 a nice number? It's a nice round number. Can you divide 400 a lot of different ways? Yeah, that's one reason why we did 360. You can divide 360 a lot of ways. It could have been 5. There could have been 5 total degrees in a circle. I need you to understand this. There are a lot of choices that were made in mathematics that when you take a math class, a good chunk of the math class is just understanding what the choices were made. We made a choice and we're like, let's make it 360. So we took a pizza and we're like, let's cut it into 360 pieces. You ever been to one of those parties where the pizza, the slices are like long and skinny and you're like, hey, it's so much. All right. So that's kind of a silly thing. Also, they're completely made up. Degrees are completely made up, even more than everything already is, because they didn't have to. So, radians are an actual physical measurement. They are better. They are better. They are better. When in doubt, you use radians. What's this guy? That's the center. That's the radius. Yes. Just go to the chase. If I pick that radius up, put it out here, and I go, and I bend it. Yes? Yeah. And I put it back on the circle. So this is the length of a radius. That is, do you guys see if I do that? Have I not gone through an angle? We call it, I don't know if I put it on here, subtending an angle, but do you guys see that I've gone through an angle? If I have a crop circle out in my field, yes? Farmer Jeff, I go out to my field, there's a crop circle, I'm like, aliens! And I start to walk along the outside of this, I am going through an angle, am I not? If I walk along, if I start here and I walk along, I'll walk along. And then I've gone through an angle. Yes? No? I'm gonna assume you're cool with that. No? What's up? Have I not gone through an angle? Thank you. Okay, thank you. That's all I need. We call that angle 1 radian because how far did I go? 1 radius. So that's where the word radian comes from. It's a number of radiuses. Radii. And real quick, what's the formula for the circumference of a circle? Kick ass. So let me ask you, if I went 5r, I'm not trying to say this, if I went 5 radiuses, wouldn't that be 5r? You with me? Isn't that silly? So how many radiuses do you go all the way around the circle? The answer's right there in your face. 5r is 5 radiuses. How many radiuses do I go to get all the way around the circle? 2 pi. 2 pi radiuses, right? Not 2 pi, 2 pi. Radiuses gets me all the way around the circle. So how many radiuses get me halfway?
Pi.
Pi. Okay, so right here, this angle is pi radians. What is it also? In degrees, what is it?
180.
180 degrees. So every pi radians is 180 degrees. That's like 12 inches is 1 foot. Does this sound familiar to anybody? I'm gonna take that as a no. All right. Some of you guys? Yes.
Does that mean each radian is like 57?
Yes, good. Yeah. So you could, if you take pi, so every pi radians is 180. So 1 radian, if you guys took any chemistry, this should look familiar. Pi radians in 180 degrees. So the radians cancel. What's 180 divided by pi? About 57 something. So this is roughly 57 something degrees here. Okay. How are we doing? Why is radians better than degrees? Because radians is built on the radius, which is a physical measurement, instead of some number. Somebody in the past went, I like that number.
It's consistent, like radians.
Yeah.
It's, I mean, like no matter what, it's always gonna be the same amount of start.
Yes, in fact, what you just said, Ezekiel,
It's a percentage.
if I have a circle this big, and I go radius, and I go radius,
Yeah, you.
right?
Yeah.
That's 1 radian, correct? Well, if I just make everything bigger, oh shit, everybody hold on to your butts. Oh, for me, that's pretty good. All right, give my Pokemon ball a break. Somebody sat on it, shut up. I made a bigger circle, correct? Didn't the radius get bigger? Then I would walk equivalently bigger this way, so I'd end up going through the exact same angle. That's why radians work. They don't just go with 1 circle, they go for all circles.
Yeah, radians.
So radians work. Say?
It's a fraction. Like.
It's a proportion, yeah, I see what you mean. It's a
Yeah.
portion of it, yes, I got you. All right, I didn't mean to do all that, but.
Like you said, it's like 57 out of 360 or something like that.
You could, I don't normally go that route.
Like you could probably,
Yeah,
if
yeah.
radius is like a
Yeah,
fraction, probably.
so they go roughly 3.1415 blah 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 radians, that'll get me over to 180 degrees, because that's pi radians, okay. So when I say what's cosine of pi over 6, pi is 180 degrees, 180 divided by 6 is 30, I just asked you what cosine of 30 degrees is, right? That's the translation you do when you learn a different language. Radians is a different language. We're both talking about angles. We're just using different words for them. Degrees versus radians. Okay. Maybe? No? And if this does not sound like at all familiar, holy shit, come see me. Okay. I hope you guys take that though. Wait, I mean it. You gotta advocate for yourself. Okay. So let's do this. Let's finish this one up. I went off on a total tangent there. No pun intended. We did this. This is kind of, my whole point with radians is, okay, that's right. Let me ask you this. If I go through an angle of 1.2 radians, what does that physically mean? How far would I walk here? What would you have to know to figure out how far you walked? I went through an angle of 1.2 radians, and I want to know how far that would be a walk around the outside. I'd have to know what? There's something I didn't tell you. I'd have to know the size of the radius, yes? Because what does 1.2 radians mean? How many radiuses? How many radiuses? 1.2. 1 radian is 1 radius, 1.2 radians is 1.2 radiuses. So if I tell you the radius is 11, let's say 10, what's this? What's this length of this arc? We'll call it arc length. Huh?
12.
12. How did you get that? You took r times theta. That's arc length. Okay. That's arc length. And you can talk about it in many different ways, but they're all silly because all a radian is a number of radiuses. So of course, if I multiply that by how big a radius is, I'll see how far I would go. That's fundamental, right? Okay, so that's why that's that. I'm not gonna, that's enough time on that. So the area is 1/2 r squared theta, just accept it. I think last time we got to this point, so a perimeter of 32 inches. So if I draw a pizza slice, just pick this pizza slice up and put it here. This is r, this is r, this is r theta, yes? So then the perimeter would be 2 r's and an r theta. And that has to be 32 inches. Okay, so if you weren't here yesterday, I mean, you know what I mean. Give me a break. Then that kind of stuff. You want to catch up. So the whole point of these kind of problems, that was all review. The whole point of these problems is they tell us something, they ask us something. I set up a formula for what they ask us so I can attack it with calculus. So they're going to ask us to maximize, minimize, make it the closest, make it the biggest, make it the smallest, whatever. Those are optimization questions. I want to optimize, in this case, I want to optimize my pizza area. That sounds like a generally good mission to be on. If you don't like pizza, I'm sorry, you can imagine something else. So they tell us about the perimeter, yes? They ask us to maximize the area. So I wrote a formula for what they tell us, and I wrote a formula for what they ask us. Now, if you just look at this formula, does it feel like r and theta can be whatever they want to be? Just look at this formula. That's it. Could I make r 9 and theta 111.3? You with me? I could do that, correct? But in this problem, does that jibe with the rest of the problem? Can r and theta be whatever they want to be? Because this weird dude needs to have 32 inches exactly perimeter, right? So I have to use this in here. A fringe benefit is there's too many damn variables. I don't want to do product rule. Do you want to do product rule? No. So I'd much rather solve for a letter here and then get rid of it. Now let me tell you, it doesn't really matter which variable you solve for. There's a couple things to look. Like this one is equally easy to solve for r or theta. If you disagree, then you solve for the one that's easier. I will tell you this, do you notice how if you solve for r, you're gonna have to square it? And that could potentially make this gross. So I would say solve for theta. I don't know if you guys see what I'm saying. So there's a few things that will tell you. You could solve for whatever variable you want to. The whole point is you have to use that information in the function. So I don't care which variable you solve, I don't give a shit. You get to pick them, which means, okay, when is it better to do this or that? Well, I'll tell you, if you try one, you plug it in, you're like, I don't like the looks of that. Go back and do the other one and go, well, the first one was better. Then you just do the first one, right? You could do it trial and error. But here, I'm gonna square r, so I'm not gonna solve for r. That would kind of suck. How do I solve for theta? Ooh. How do I solve for theta?
Divide.
No. How do I solve for theta?
Take out the r.
2 r.
Subtract 2r, divide by r, yes? 32, subtract 2r, divide by r. Yes? Okay. Can I rewrite my area formula now?
Yes.
Yeah. And what do you notice? Two things happen that are kind of nice. One r cancels, so you don't have a fraction anymore. And then the 1/2 can cut each of these in half. You guys see that? So you can simplify this. Are you guys at all with me? So if I kill an r, holy shit, if I cut things in half, all right, let me do the one thing at a time. I'll kill an r. Yes, die. And then I distribute this. There is my function. It's a function of one variable. Is it the function that they wanted me to optimize? Yes. They wanted me to maximize the area. So I'm gonna attack this with calculus. How am I gonna attack it with plus or plus? What do I mean by attack it with calculus? How do I find the maximum? Take the derivative, set equal to 0, find the worst undefined, blah, 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 blah. Yes? We're trying to find the absolute, so you would actually, well, what I do, if you look at the, let me give you this. If you weren't here last time, you're gonna want, where to go? This one. Yes? So I know some people need this one. Who needs this one? This sheet has some worked out examples. Real good. Oh. Okay, so let's do this. Yes, we're gonna fit this in. Oh, this paper I've written all over. Here we go. Let's look at this first problem. Let's look at something nice and fresh here. So I'm really sorry if you were at the workshop, but we're gonna talk about orcs and hobbits again. This is a classic calculus problem. For some reason, we love freaking rivers and putting fences next to them. That's, we had our way, there should be fences next to every river. So we have a river, and I want to set up a pen for some reason I've got a bunch of orcs and hobbits as pets, right? And the hobbits are probably not happy about that, but I give them a second breakfast and they're okay. Sorry if you don't like Lord of the Rings. Do you understand the point of this problem? I don't have to use fence along the river, correct? So, if I got 300 feet of fencing, I want to use all of it, and I want to give my orcs and hobbits the most space to roam. But I don't want them to roam and go away, because they're mine. When I draw this, I would draw something to represent the river. So this is one side of my pen, and then you just make the pen. Now what's missing? If you read through that problem, what else do I want to include? Yes, I don't want my orcs to get over to my hobbits and eat them. Or maybe it's a big ass hobbit's kind of like bully the orcs. I don't know, could go either way. So I'm gonna put, I didn't say it has to be in the middle, but I'm just gonna draw in the middle just for myself. So there is a visual representation of the problem. So I have 300 feet of fencing. I've got to construct those lengths, yes. So it's not, you see how it's not really perimeter I'm talking about? Because perimeter normally would not include interior stuff. But the interior is fencing, and I only have 300 feet of it. What needs variables? Yeah, the size. How many variables do I need?
3,
No.
2,
2, good. Because how long is this?
X.
You want to call it X?
Fine. 3 X's.
Sure, okay. We'll call that X, then that's X, then that's X, and what's this side going to be?
1 Y.
Y, okay. That's fine. You can call them whatever the hell you want to. But you have to understand, if it's going to be a rectangle, then those X's have to be the same. You don't give them different names. That will make your math really gross. Let me stop for a minute. Drawing a picture is not a part of every problem, but it's a part of a lot of them. And when you draw the picture, that's what tells you what variables you need. Yes?
Instead of technically would the circle be more, or like half circle be more efficient?
I could make a problem like that for you.
Actually, yeah, that sounds like a terrible idea.
So for some reason, this is the dude who wanted 32-inch perimeter pizza. He also wants only rectangular
If
fence.
nothing else, I'm pretty sure it would be a real pain to build a circular fence.
Yeah, it's normally pretty hard to get the fence to bend. I'm not like
Well, I mean,
I know they got water benders and air benders. I don't know if they
Yeah,
earth benders, but I don't know if they didn't have wood benders. It's like,
I mean,
Okay, sorry.
yeah.
all right. I did talk last time about silos, didn't I?
Mm-hmm.
And that the circle would be.
Yeah.
That's not this problem. We know it's going to be rectangular.
Yeah.
Right? Okay. Real quick. Oh man, it just takes so long to do anything. Real quick, just because. So let me just pull out the important parts of this. There, and then I'm not gonna draw the river, yes? Can somebody give me, and there's 300 feet of fencing, correct? Just very quickly, can somebody give me what this side might be? Just give me a number for what this side might be.
200.
All right, so let's go 100. How much is left?
200.
So what are each of these sides then gonna be? Don't overthink it, it's just 200 divided by 3, right? Whatever the shit that is. You with me? So if this is something that constrains these to be something, correct? And we are looking for the sweet spot. So we could guess and check until we go insane, or we could let calculus help us, right? Because it'll find the exact answer, yes.
I was gonna say just since we know what like the length of the perimeter is,
Yeah, okay, yes, we're good, that sounds good. I think I heard.
Calculate x because x would be like p minus y.
No, let's not get too far ahead. So where do I put my 300 feet of fencing? It goes into making what? How many x's?
3 X's.
Yeah, 3 sides that are x long, so 3 of these plus
Y.
1 of these. Yes? That's what I call what they tell us. Another teacher might call it the constraint function. Because that is a constraint. We only got 300 feet of fencing. So this is a formula for what they tell us. So I think I've told you guys before that it's really unfortunate you don't get a lot of practice with word problems, which is one reason why I did those 4 workshops, because to me this is the harder setup. We did related rates before, but I feel like those were easier to set up, although you guys might not agree with me, but wait till you these to set up are more algebraic. So you don't get a lot of practice with word problems. To be really good at word problems, to be really good at math, you have to know how to break things up. So I'm trying to give you a very concrete, okay, let me focus on what they tell me. Nothing else matters. 300, I know that, what is it? Fencing, it's kind of like perimeter. Okay, so you can focus totally on what do they tell me, let me set up a formula, yes? Now what is it that they ask us about? Well, I tell you, it's the area, right? They're trying to maximize the area. So from this picture, what's the formula for the area?
X times Y.
That's insane. Is everybody all right? Thankfully, it wasn't everybody's phone. That would have been different. Zombies. I did say perimeter. I didn't mean to. Damn it. Solve the perimeter equation. So now, if I use what they tell us in what they ask me, so there's 2 things here. Too many damn variables, and this doesn't have the 300 information, so it's not really the right formula for the situation. Which variable is easier to solve for?
The what?
Which variable is easy to solve for?
The X.
I would say y, because x would introduce fractions. Now, if you want to, I don't care. You should be able to do either way. If I force you to do the fraction way, you should be able to do it. But I love math, and I'm not going to do that to myself. Because I'm a human, and fractions are one more place humans make
Y
mistakes.
First.
Are you guys with me? You could solve for whatever variable you want to. There's 2 things I look at. Which one's easier to solve for? And also, like I did earlier, I'm gonna have to square one of them, so maybe I want to do the other one. This one's just x times y. I can solve for either one. I'm gonna pick y. It's got less shit to do to solve for it, right? Now what do I do with that? Plug it in. So how do I rewrite my area formula now?
100 x minus.
A equals X times 300 minus 3X.
Now, this is actually a problem you could have done in pre-calculus because it's a parabola. You can find the vertex, negative b over 2a, blah, blah, blah. But here you can do the derivative, set it equal to 0, get the critical numbers. Are you guys with me? So the minute you get the formula set up, you are back in 4-1. 4-7 adds, they say, we're not going to tell you the formula. We're going to give you some information. You try to set it up. So we do, and then, oh, now we're back in 4-1. It's like they gave me that one and said, find the absolute max in this case. Yes.
Now, that's area or the perimeter?
Huh? This is definitely,
Area.
yeah. So we solved this equation for a letter. We solved it for y.
Oh, yeah.
And then we plugged it into the area equation. Yeah. Okay. Calculus would come next. So, let me do two things. Yeah, that's good. Okay. I'm gonna give you the answer key for this sheet. And then we're gonna take a break. And when we come back, we'll work on some other optimization problems. You guys will work on some optimization problems. And you've got all kinds of examples to look at.
So he just flipped him around, that's all.
You'll notice I use different variables on mine, but it's okay.
Yeah, you just flipped.
Same variables, different place because to me I saw a y-axis, x-axis, but same stuff. I actually did the calc real quick, but I didn't check it to see if it was an actual map, so you'd have to do that. So what did I say? Are we gonna take a break now? Yes, let's take a break now. Come back at 15 past. How do you guys work in groups on some stuff? Okay. Oh, I can also give you the practice test. In case you want to look at that. One of these.
No.
Okay. So guys, this problem is a really good example of why it's important to keep the two ideas separate. So we have an idea about area, and we have an idea about cost. The cost is dependent on my area, but my area doesn't give a shit how much something costs, right? So area is totally its own thing. So if I draw the situation, yeah. And I want you to understand, I completely understand those of you who were like, well, don't I want to make the smaller side, the less expensive? That's what the math is gonna do. When I draw that picture, it don't matter what it looks like as long as it's a rectangle. It don't matter what it looks like. It's just a visual anchor. I don't, as the person, I don't have to pick the right side. The point of the math is to see which side should be less expensive. How long should it be? We know it should be not as long. So I'm gonna purposely pick one of the big sides. I'm gonna say that's my more expensive one. But before I go to cost, expression for the area of course is just x times y, and I tell us that that's 180. Okay. And when you plug shit into a formula, you don't have to bring the units with you. That'll just get in your way and make things look worse. The cost, if I want to figure out how much something costs, and I got several parts, I just add the cost for each part. Yes? So how much is this side going to cost? How long is this side? X feet. And it's how much per foot? 15. So how much total money? 15x just to get that side done, correct? What else do I have to get done? All right, good. The other side will be 10x plus. So now I got these two sides set up. 10y plus 10y. So cost is just add up all your costs to get the total cost. So this is going to be 25x plus 20y. Now, some of you guys might have your x and y switched from me. It doesn't matter worth anything. Some of you guys might have L and W. Who gives a shit? I kind of want someday somebody to do happy face and caret. That would be nice, because it doesn't matter what symbol you use. Okay, so I've got my area formula set up by itself. Along the way, I set up variables that help me figure out the cost function. It's set up by itself. Now the two of them interact, right? If I take my area function and I solve for one of the variables, I say length, it don't matter none. I'm gonna solve for y. If you solve for x, yay, it doesn't matter. So now I can rewrite my cost function using this information. Now some of you guys, again, does everybody understand that if you did 25 times 180, you're fine, you just solve for the other variable? I need you to understand. Did anybody do 25 times 180? Okay, that's beautiful. I didn't. Who cares? The variables are interchangeable. So my x is your y, and so then my cost function is now 25x plus 36, what is it? I can't think. 3600, x to the negative 1? Oh yeah. Is everybody with me? So one thing to look at, I have to minimize cost. That means that I eventually need a cost function, because then I can attack it with calculus, get critical numbers, get the minimum. So everything in this is to eventually set up the cost function, because I need a cost function so I can minimize it. So then I do C prime. And then everybody's very excited about solving this. Now real quick, there is a critical number that makes it undefined. You guys see it? What makes this undefined? 0. But if x is 0, then I have no area. If I make x 0, I'm screwed. Okay. So that's bad. So let's see what I did from here to here. If you multiply both sides by x squared, and you divide both sides by 25, you get here. And then what do I do? Then what do I do? Square root. Now I normally hit plus or minus, but I know I'm going to throw out the minus, right?
Don't have negative.
Yeah, because I really don't want to make a negative side length, because that would freak everybody out. Now 3600 divided by 25 goes in either, but what's the square root of 3600? You know it. 16. What's the square root of 25?
5.
And what's 60 divided by 5? 12. 12 what? No, that's square. 12 feet. And what is it that I ask for? No, I don't. Well, I do ask then, but by the dimensions. So what's y? How do you figure out y? Do I have an equation that has y and x? Yeah, so y is 180 divided by 12, which is 15. I say with confidence, yes, 15. All right, let me stop for just a moment. We're not done, but the minute you get the function set up that the thing said minimize or maximize, if it said find the closest distance, okay, get a distance function, attack it with calculus, right? So you have to pay attention. What am I trying to maximize or minimize? I know I need a function that represents that, and then I can attack it with calculus. So I take the derivative, see where it's undefined, set it equal to 0, bam, 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 bam. How do I get the cost now? I don't know, do we have a cost function? Yeah, we have 2 of them. I could use this one, because I know x and y, don't I?
Put that 12 by 15.
Yeah, so the cost will be 25 times 12 plus 20 times 15. And by the way, real quick, what side did I say was the most expensive? I said X. And which side was the shortest? X. Do you guys see what I mean? That's math's job. That is math's job. It better do some shit, because look at all the work we did. Math better do something. So it don't matter what side I pick. If I pick the side, it's going to make it the side it's supposed to be. It's going to make it 12. If I would have picked Y, then Y would have been 12. That would have come out in the work. Okay, maybe. And then what is it? I don't know. 300 plus, you could do a jet 3. Oh, that's 600. Is that right?
Yeah, that's the reason.
And just to push my luck. So you guys remember I said if you have a 4-sided figure, it should come out to be a square? You guys all understand why this was not a square? Because there's a cost involved. So of course I had to make one of the sides shorter so the overall cost was less. But what's the total cost? I don't know if you guys are gonna be with me or not. The total cost this way is 300, and the total cost this way is 300. So in terms of money, it is a square. Whatever, Jeff. So I don't know if any of you guys kind of understand what I'm saying. It's kind of cool that there's always a square in it if it's a 4-sided problem. Did it end up being a square geometrically? No, it's 15 by 12. Did it end up being a square in terms of money? Yeah, it's the same amount of money this way as it is that way. All right. Did everybody get a practice test? We don't have time to do the other problem today, so we'll do it next time. But so next time, Monday will be our review day. If you didn't get this note, we're not having a test on Monday. It's been pushed to Wednesday. So I'll have your quizzes graded Monday on the answer key, all kind of stuff. Okay.